Hello and welcome to the Stanton 101 video on vectors. In this video, I will be covering finding the angle between two vectors, drawing the resultant vector, and scaling a vector. Let's take a look at a problem from Mr. Harper where vector A is 3, 4 and vector B is 7, 1. First, we need to sketch it out here and label both vectors. So let's call this angle here angle 1, or theta 1, and this angle here, theta 2. The angle in between them can be labeled phi. Phi can be calculated by theta 2 minus theta 1. We can find both of these angles by taking the inverse tangent of the two vectors. So we'll go ahead and label that here. This would be arctan of 4 over 3 minus the arctangent of 7 over 1. When you plug this into your calculator, make sure that your mode is set to degrees so that after you hit enter, you should get 45 degrees. There is another way to do this though, and this way can be done without a calculator. I have already redrawn the vectors, so all that's left to do is label them. So we can label that vector A and label this one vector B. This time, we can find phi by multiplying both vectors together. So now what we can do is we can multiply vector A by vector B. And how we have to do this is we have to multiply both x components and both y components together, and then you add the two. So this would equal 3 times 7 added to 4 times 1. And then this gets us 25. Next, we have to find the magnitude of both vectors. So we can go ahead and find the magnitude of vector A, which is shown by the double bars on both sides. So the way we find this is 3 squared plus 4 squared equals the magnitude squared, which is 25. So what we have to do is we have to square root 25, and then that equals 5. We can do the same thing for B, where the magnitude of B will be 7 squared plus 1 squared equals 50. Then, like we did with 25, we have to square root 50, and we get 5 root 2. So now we have to take both magnitudes, 5 and 5 root 2, and plug it into this equation. This formula here says that phi equals the arc cosine of the dot product of vectors A and B over the product of the magnitudes of both vectors. So we have already determined that the magnitude of vector A is 5 and the magnitude of vector B is 5 root 2, as well as the dot product of vectors A and B equals 25. So now we have all the necessary information in order to find out what phi is, and so all you have to do is plug it into the equation so that you get the arc cosine of 25 over 5 times 5 root 2. So the 25 on the top and the 5 times the 5 on the bottom cancel out, and you're left with phi equals the arc cosine of 1 over root 2. This can be rationalized so that you get phi equals the cosine, arc cosine of root 2 over 2. And if you remember from your unit circle values, the arc cosine of root 2 over 2 is going to be equal to 45 degrees. So we get the same answer as before, but this time you did not need a calculator in order to get the same answer. Now let's practice scaling a vector. This is where you resize a vector, and you can either make it so that it goes in the same direction or the opposite direction of the original. A practice problem for this would be the vector 5, 12. For simplicity, we can choose a Pythagorean triple to allow for nice, easy whole numbers. If we want to scale this vector to a length of 19.5 in the opposite direction, we can set up this equation by first drawing the vector and labeling it vector C. You can scale a vector by dividing the desired length over the magnitude of the vector and then multiplying that by the vector quantity. If we want to resize the vector in the same direction as the pre-existing vector, then we don't do anything to the sign, but if you want to make it go in the opposite direction, which is what we want in this case, then you can add a negative in front. By using this formula here, we can plug in 19.5, which is our desired length, over the magnitude, the vector C, which since it's a Pythagorean triple, will be 13. And then we can multiply this by the vector 5, 12. And then since we want it in the opposite direction, we're going to have to put a negative in front of it. And since both 13 and 19.5 are divisible by 6.5, we can go ahead and rewrite this as negative 3 over 2 multiplied by our vector C, which would be 5, 12. Now all that's left to do is multiply the negative 3/2 to the 5, 12, and this gets us a resultant vector of negative 15, negative 14. This here is going to be in the third quadrant, which we can go ahead and do an approximate sketch, and it would kind of look like that. Next, here's a problem on resultant vectors. If we have vector A at 5, 3 and vector B at negative 3, 7, and we want to find the resultant of vector 4A plus vector 3B, the first thing we have to do is to multiply both of the equations by their respective coefficients. The first thing we have to do is multiply vector A by 4. So we can set it up like this, and then that equals vector 20, 12. We can do the same thing to vector B, which is multiply it by 3 to get negative 9, 21. Now all that's left is to add these two. So what we can get is the vector 20, 12, and then added to the vector negative 9, 21. When we add these, we get the vector 11, 33, which can be graphed in the first quadrant, something kind of like this. So this graph here would be the resultant vector of A and B. Lastly, here's a problem from Harper's vector packet for us to use. If a man hikes 10 kilometers on a bearing of 70 degrees true, then walks 15 kilometers at a bearing of 180 degrees true, what is his return vector? First, we need to set up this problem by drawing some axes. Now let's draw a vector that's about 10 kilometers approximately at a rough degree of 70 degrees from the axis. So this would be the 70 degrees because this is talking about bearing angles, and cardinal direction references true north, so that's what this means when it says 70 degrees true. It means 70 degrees this way away from true north. Since we have our point here, let's go ahead and draw another set of axes so that it will be easy to label alternate interior angles later on. Let's go ahead and label this distance 10 kilometers, and let's go ahead and label this 20 degrees because 20 is the complement of 70, which is how big this angle is. Due to the alternate interior angles postulate from geometry, we can go ahead and label this angle 70 degrees as well because this and this are alternate interior angles. We can assume that this is a right triangle because axes will always intersect at a 90-degree angle. We can also go ahead and label this direction 15 kilometers because if you go 180 degrees true from this spot right here, that would be going 180 degrees away from true north, which would mean due south, which gives us the 15 kilometers. So now what we have to do is draw the resultant vector from A and B, and let's label this C, and then the 10 kilometers can be side A, and the 15 kilometers can be side B. Now, in order to find the length of side C, we have to use the law of cosines, which says that C squared equals A squared plus B squared minus 2AB cosine angle C. So now let's go ahead and label the angles. The angles are always across the side that corresponds with the same letter. So angle A would be across from side A, angle C would be across from side C, and angle B would be across from side B. So now all we have to do to find the length of side C is to plug in what we know into the law of cosine. So we have 10 squared plus 15 squared minus 2 times 10 times 15 times the cosine of 70 degrees. This results in C squared equals 222.39 kilometers. And so if you square root that, then you get C, which is equal to 14.91 kilometers. And we can go ahead and label that near side C for future reference. Now, all that's left is to use the law of sines to find angle A, which is also the return angle. So, what we have to do is we have to do the law of sines, which is A over sine A equals side C over sine angle C. Now we know the length of side C, which is 14.91 kilometers, over the sine of 70 degrees, because that is the measure of angle C, equals 10 kilometers, because that's the length of side A, over the unknown sine of angle A. So all that's left to do is a little bit of cross multiplication. So we get 10 sine 70 degrees divided by 14.91 kilometers is equal to the sine of angle A. So now we know the quantity to get the value of sine A. What we have to do is we have to do the inverse sine of 10 sine 70 over 14.91. Now, if you plug this into your calculators, you should get that angle A is equal to 39.06 degrees. Now, we are not quite done, but almost. Now that we have the value of angle A, we have to subtract this from 360 degrees in order to get the bearing in terms of cardinal direction. So if we do this, we get 320.94 degrees true for 14.91 kilometers. And this would be your answer for what the resultant vector of this problem will be. That is the end of the video, and I hope it helped. Please let us know what other topics you would like covered either in the comments or on Instagram. Thanks again for watching, and stay tuned for more videos soon.